students. In the previous session, we had discussed about the nature of bonding in carbon, and also we have learned how to draw the electron dot structure for covalent compounds. And in this session, we are going to understand the versatile nature of carbon, which results in the formation of large number of compounds of carbon. And also we will discuss about the different classes of carbon compounds in this session. Okay, let's get started. Yes, my dear students, in the beginning of the chapter, we have learned that there are many things which are around us that contains carbon. Right from the clothes that we wear, the soaps and detergents that we use, fuels, they consist of carbon, plastics, rubber, dyes, all these substances contain carbon, which means carbon can form large number of compounds, and practically more than 3 million of carbon compounds exist. So what is the reason behind it that carbon can form such a large number of compounds, that too all these compounds are stable? It is due to the versatile nature of the carbon, which will lead to the formation of these large number of compounds. Yes, let us understand the nature of carbon. It is due to mainly two reasons that carbon can form huge number of compounds. Yes, what are they? That is tetravalency of carbon. Means carbon is having valency 4, so that it can share its 4 electrons with other atoms of carbon and also with atoms of other elements. So it can form 4 bonds. And also not only this, it can form bonds with many other atoms like oxygen, sulfur, chlorine, hydrogen, nitrogen, bromine, iodine in this way. It forms stable bond with these atoms. And the second reason is that it is it shows the property of catenation, which means it is capable of bonding with other atoms of carbon, resulting in the formation of large number of molecules here. Okay, let us understand its versatile nature here. Yes, carbon is having tetravalency. Carbon can form, yes, it can form bond with 4 different atoms of carbon and also with atoms of other elements. It can form bond with atoms of sulfur, nitrogen, oxygen, chlorine, hydrogen, iodine, etc. Yes, this carbon atom can form bond with all these atoms and also many number of atoms of other elements. This gives rise to formation of many number of compounds. And the bond between the carbon and these elements, atoms of these element is quite strong, because it is due to the size of carbon atom. The size of carbon atom is small. So the bond formed between the carbon atom is quite strong. Why it is strong? Because the size of the carbon atom is small, which results in the shared pair of electrons to be held strongly by the nucleus. The shared pair of electrons between the two atoms, that is in between carbon and any other atoms, these shared pair of electrons are held together by the nucleus with strong force of attraction, so that it is not easy to break these bonds, because of which carbon shows bonding with these atoms. Yes, and also another one reason is it is due to the catenation property. What is this property? It is the property of carbon that it can form bond with other 4 atoms of carbon, resulting in the formation of large molecules. Yes, carbon can form bond with other atoms of carbon, resulting in large molecules. Yes, carbon can form bond with other carbon atoms, like it can form chain structures. Carbon can bond with other carbon atoms to form chain, and also they can form branches. They can form branches like in this way, and also they will form rings. These will result in the formation of rings of many number of carbon atoms. This gives rise to formation of large number of carbon compounds. And also they show single bond between the carbon atoms, and also they will have double bond between the carbon atoms, and they can have triple bond between the carbon atoms. In the previous session only we have discussed that when there is sharing of one pair of electrons, there is a single bond. If there is sharing of two pair of electrons, then it results in the double bond. When there is sharing of three pair of electrons, it will result in the triple bond. Yes. And when there is formation of only single bond between the carbon atoms, then such compounds are called as saturated carbon compounds. In case of CC, single bond. In the molecule, there is only presence of carbon single bond. And when there is presence of double or triple bond between the carbon atoms, then those compounds are called as unsaturated compounds. And as I have already said that the bond between these carbon atoms is quite strong. The covalent bond, it is very strong because the size of carbon atom is small, and the shared pair of electrons between the carbon atoms, it is sharing a pair of electrons between them. These pair of electrons are strongly held by the nucleus. This results in the carbon-carbon bond to be very strong. Yes, carbon-carbon bond is very strong. When the bond is strong, this will result in the formation of stable compounds. So, this carbon which can form large number of molecules, they exist because due to stability of this carbon-carbon bond. Even some of the elements like sulfur or silicon, they can also form chains or rings. But these are quite reactive. Some of the catenation property is also seen in the elements like silicon or sulfur, but these compounds are not that much stable as that of carbon compounds. They are quite reactive. Silicon can form chain up to 7 or 8 carbon atoms, 8 silicon atoms. Yes, it can also form chain, but these compounds are quite reactive. The bond between them is not that much stable as that of carbon-carbon bond, because of which a large number of molecules are existing in the carbon-carbon compounds, because of which there is a existence of large number of carbon compounds. Okay. So, overall, these two properties of carbon will lead to the formation of large number of compounds, that is both tetravalency and catenation property. Even there are many elements which have tetravalency like silicon, germanium, but these both the properties will lead to the formation of large number of compounds which are stable. Yes, this is very important. You have to note these two properties. Okay. And the carbon compounds which we are studying, they are called as organic compounds. Why the name is given as organic compounds? Because initially these carbon compounds were extracted from the living systems only, which were occurring naturally. So these carbon compounds are named as organic compounds. Initially these compounds means compounds of carbon. Initially the compounds of carbon were extracted from living organisms. So these compounds were called as organic compounds. We ourselves are also made up of carbon compounds. The proteins, many biomolecules, they contain carbon. Yes. Later, it was identified that these compounds can also be synthesized in the laboratory. The compounds of carbon can also be synthesized in the laboratory. And Frederick Wöhler was the first scientist to synthesize the organic compound, that is urea. He was the first scientist. Frederick, he was the first scientist. He synthesized the first organic compound in the laboratory. What was that first organic compound that was synthesized in the laboratory? It was urea from ammonium cyanate. It was the first organic compound that was synthesized in the laboratory. Yes. Again, there are many number of organic compounds that can be made artificially. Initially, it was thought that only these compounds of carbon were extracted from the living organisms. So, these were named as organic compounds. Until today, we will study the compounds of carbon in the branch called as organic chemistry only. Except some of the carbon compounds like carbon dioxide, carbon monoxides, or hydrogen carbonates or carbonates, we will study the rest of all the carbon compounds under the organic chemistry. Okay. And now we are going to study the compounds of carbon. Yes, hydrocarbons, these are the compounds of carbon. As the name itself indicates that it contains hydrogen and carbon. These are the compounds of carbon and hydrogen. And these contain the atoms of carbon and hydrogen only. These are called as hydrocarbons. These are the compounds containing carbon and hydrogen only. Yes, among the hydrocarbons, we will see different class of hydrocarbons. Okay. There are basically two different hydrocarbons. They are saturated hydrocarbons and unsaturated hydrocarbons. In saturated hydrocarbons, we will see between the carbon atoms there is only carbon-carbon single bond. Whereas in case of unsaturated hydrocarbons, we will see there is a presence of at least one carbon-carbon double bond or carbon-carbon triple bond. Yes, these hydrocarbons contain only carbon-carbon single bond. Whereas in case of unsaturated hydrocarbons, these contain at least one double bond or triple bond between the carbon atoms. And recall again, single bond means there is a sharing of only one pair of electrons. Double bond means there is sharing of two pair of electrons. Triple bond means there is sharing of three pair of electrons. Yes, we can give many number of examples. This is a saturated hydrocarbon. It is called as ethane. We will come to the naming of these hydrocarbons a little bit later. Now just understand about the saturated hydrocarbons and unsaturated hydrocarbons. Here there is presence of only carbon-carbon single bond in these molecules. It is ethane. We are seeing here carbon-carbon single bond is present. Whereas in case of unsaturated hydrocarbons, there is either carbon-carbon double bond or triple bond. In this way, there is a presence of double bond, and also there may be presence of triple bond also. And understand one point that in case of saturated hydrocarbons, there may be only one carbon atom also. There may be existence of compound of one carbon atom also, as in case of methane. Here there is no presence of double or triple bond. Whereas for formation of double or triple bond, we need two carbon atoms, at least two carbon atoms. As in case of ethene and ethine. There is no existence of any molecule which contain only one carbon atom in ethene or ethine. There must be presence of at least two carbon atoms so that there is a double or triple bond. Yes? Yes. In saturated hydrocarbons, we are going to study about the alkanes. Alkanes are the saturated hydrocarbons. These are saturated hydrocarbons with the general formula CnH2n plus 2. As we have already learnt that carbon forms many number of compounds, and these alkanes are saturated hydrocarbons. They are having the general formula CnH2n plus 2, means they have only carbon-carbon single bond in their molecules. Yes, we have many examples for them. If it and this n represent the number of carbon atoms. If I take the number of carbon atom to be 2, then I get the formula C2H2 into 2 plus 2, that is C2H6. This is called as ethane. This is called as ethane. Means what ane represents, it is an alkane. And eth represents that it contains two carbon atoms. Depending on the number of carbon atoms, we will start the naming with pro, eth, meth in this way. We will learn about the naming that is nomenclature of this compound in the later part. For time being, understand that if the carbon atoms is only one, then we represent the compound with meth, means only one carbon. And if there are two carbon atoms, then we will represent it with eth, two carbon atoms. If the compounds contain three carbon atoms, then we will call it as prop, three carbon atoms. If it is having four, then we call it as but. Pent is for five carbon atoms. Hex is for six carbon atoms. Hept is for seven carbon atoms. Oct is for eight carbon atoms. Non is for 9 carbon atoms, and dec is for 10 carbon atoms. If the compound contains one carbon atom, we will use the meth, eth for 2, prop for 3, but 4. In this way, for 10 carbon atom, we will use dec. And here, ane represent it is an alkane. If it is alkene, we will use ene. Yes, we will come to it little later. And there can be still many examples. If the number of carbon atoms is 3, we will get the formula as 3 into 2 plus 2, that is C3H8. What can we call this compound? It is having 3 carbon atoms, so it will be propane. As this is following the general formula, that is CnH2n plus 2. It is propane. All the alkanes will follow this general formula. Yes, all the compounds of carbon, that is alkanes, they will follow the general formula CnH2n plus 2. If I write C3H8, then it is an alkane. And it shows that there is the presence of only single bond between the carbon atoms without any doubt. Yes. And you can form many number of carbon compounds of alkanes. And this is about the saturated hydrocarbons. Then in case of unsaturated hydrocarbons, we will come across alkenes and alkynes. Yes, in unsaturated hydrocarbons, we will be studying the class of compounds called as alkenes and alkynes. These alkenes are the unsaturated hydrocarbons with at least carbon-carbon double bond. One carbon-carbon double bond. Yes, these are unsaturated hydrocarbons with general formula CnH2n containing at least one carbon-carbon double bond. If the compound contains carbon-carbon double bond, then those unsaturated hydrocarbons are called as alkenes. And the general formula for the alkenes is CnH2n. Let us write some examples. If the number of carbon atoms is 2, then what will be the formula? 2 into 2, that is C2H4. This is ethene. In the previous section only we have seen eth is used when there are 2 carbon atoms. And ene represents it is an alkene. Yes, in this way we can also write the 3 carbon atoms C2, 3 into 2, that is C2H6. It is, C3H6. It is propene. And we are going to see how these structures are drawn in the later part. Yes, for time being, understand that this name is used when there are 3 carbon atoms and it is an alkene, propene. Yes, in this way you can form many number of compounds of alkene. Then what about alkynes? These are also unsaturated hydrocarbons, but they have the general formula CnH2n minus 2. These are unsaturated hydrocarbons with general formula CnH2n minus 2. And it is very important that you have to remember this general formula. Yes, if a compound is given and you need to identify whether it is an alkane, alkene or alkyne, based on the general formula, it is very easy to detect whether it is an alkane, alkene or alkyne containing at least carbon-carbon triple bond. So, This shows that alkynes contain at least one carbon-carbon triple bond. Let us see the examples following the general formula. Let us take C2, 2 into 2 minus 2. That is C2H2. This is called as ethine. Again, eth represent it contains two carbon atom. Ine represent it is an alkyne. Yes. And you can also write C3H2 into 3 minus 2. That is C3H4. It is propyne. In this way, these alkenes and alkynes are classified. Do not get confused with these alkanes, alkenes and alkynes. Remember, in alkenes, there is only carbon-carbon single bond. In case of alkenes, there is presence of at least one carbon-carbon double bond. In case of alkynes, there is presence of at least one carbon-carbon triple bond. There is only change in one letter here. Alkanes, alkenes, alkynes. A, E, Y. There is only change in the one letter. Do not get confused with these compounds. Yes. Next, we shall study how to draw the structure of these hydrocarbons. Whenever the molecular formula is given and you need to draw the structure of those hydrocarbons, how can you write it? Yes, let us study this with the help of example. Let us take an example of ethane. Yes, it is an alkane. In the step 1, we are going to write the carbon atoms by linking them together with single bond. Yes. Here there are only two carbon atoms. I will write the carbon atoms in this way. This is called as carbon skeleton. Okay. And in the next step, I am going to satisfy the valency of this carbon atom, means both the carbon atoms, with hydrogen atoms. Yes. In the next step, see here already there is one bond between the carbon atoms. Now we have to satisfy its valency. What is the valency of carbon? 4. Again we will write the hydrogen atoms here so that valency of carbon atom is satisfied. In both the carbon atoms we have 3 hydrogen atoms. As the molecular formula is C2H6. This is the structure of ethane molecule. There are 6 hydrogen atoms, 3 for each carbon. In this way, we will write the structure of hydrocarbons. Then try one more example, ethene, C2H4. Yes, same here. In the step 1, we are going to write the carbon atoms in the form of skeleton. There are 2 carbon atoms. And see here, it follows the general formula of alkenes. Yes, it means there is a double bond between the carbon atoms. Okay, let us follow the step 2 here. Now we are going to satisfy the valency of this carbon atom with hydrogen atom. How many hydrogen atoms are present here? 4 hydrogen atoms. So let us write those 4 hydrogen atoms in the structure. 1, 2, 3, 4. For each carbon, we have written 2 hydrogen atoms. See here whether the valency of carbon is satisfied. No. Valency of carbon is not satisfied. It is still 3. Then we have to satisfy it with the help of double bond. Then the valency of carbon will be satisfied. And also from the molecular formula also we can understand it is an alkene. In this way we are going to draw the structure. Let us solve some more example for clarity. Let us draw the structure for propane, C3H8. As usual, in the step 1, we are going to write the carbon skeleton. That is, there are 3 carbon atoms here. 1, 2, 3. And in the step 2, we are going to satisfy the valency of carbon with hydrogen atoms. Why are we writing the hydrogen atoms around the carbon? Because this is hydrocarbon. And it consists of only carbon and hydrogen here. You can clearly see from the molecular formula. So, in the next step, we are going to satisfy the valency of carbon with hydrogen atoms. Each carbon should get 4 bonds. You can see in the first carbon, it is bonded to only one carbon atom, means there is only one bond here. So we will write 3 hydrogen atoms so that its valency will be 4. But in the second carbon, it is already linked to 2 other carbon atoms. Already it is having 2 bonds. So we have written only 2 hydrogens here. Whereas in case of third carbon atom, again it is linked to only 1 carbon atom. So we have written 3 hydrogen atoms for that carbon. Now overall, the molecular formula C3H shape has this structure. Then what about propene? How to write its molecular formula? How to write its structural formula? Again, as usual, in the step 1, we are going to write the carbon atoms linked together by single bond. There are 3 carbon atoms, so we will write 1, 2, 3. In the step 2, now we are going to satisfy the valency of carbon with hydrogen atoms. Again, see here, it is propene, means it consists of carbon-carbon double bond. So I can write here one double bond between the carbon-carbon atoms. Now write the number of hydrogen atoms. Here there is one bond, means still it needs 3 bonds. So 1, 2, 3 hydrogen atom. Here already it is having 3 bonds. Now its valency is to be satisfied with only 1 hydrogen atom. In case of third carbon atom, it already has two bonds. So I need to write 2 hydrogens for this. So totally I was having 6 hydrogen. 1, 2, 3, 4, 5, 6. And this double bond is because it is an alkene. And from seeing the name also we will understand it is an alkene. And by seeing the molecular formula also understand it is an alkene. Let's see propine. As usual, in the step 1, we are going to write the carbon skeleton. There are 3 carbon atoms here. 1, 2, 3. In the step 2, we are going to satisfy the valency of each carbon atom. And by seeing the name, we can see here there is a carbon-carbon triple bond. And by also seeing this formula also we can understand there is a presence of one carbon-carbon triple bond. So I will write one carbon-carbon triple bond. Now satisfy the remaining valency of the carbon atoms. Okay. There are 4 hydrogens here. We have to write 4 hydrogen atoms for this structure. Here there is one bond. So remaining 3 hydrogen atoms will form the bond here. And this carbon, the valency is already satisfied. Always remember that the valency of carbon is 4, and if there are 4 bonds around it, then do not add any atom to that bond. Okay. So here we are not adding any hydrogen as its valency is already satisfied. What in case of this carbon? Still it needs one hydrogen atom. So this is a structure for propine. And also we can write the electron dot structures for these compounds. Okay. Let us see. In your examination, questions may be asked about the electron dot structures, molecular formula and also structural formula. Yes. Now we shall study how to write the electron dot structure for these hydrocarbons. Let us draw the electron dot structure for ethane molecule. Yes. The molecular formula is C2H6. For drawing the electron dot structure, we have to write the valence electrons around each atom. For carbon atom, we are having 4 valence electrons. Yes. 1, 2, 3, 4. And for another carbon atom, C 1, 2, 3, 4. There are only 2 carbon atoms here and there are 6 hydrogen atoms here. For one carbon atoms, they will form bond with 3 different hydrogen atoms. Hydrogen has only one valence electron. Each hydrogen is having one valence electron. Now count the number of electrons around each atom for this carbon. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And in this molecule, there is a covalent bond between this carbon and this carbon atom also, that is single carbon-carbon bond. And with three different hydrogen atoms also there is covalent bond, and between these hydrogen atoms and carbon also there are three different covalent bonds. Yes, this is electron dot structure for ethane molecule. First what we have done, we have written the carbon atoms here. Around each carbon atom we have written the valence electrons, and they form bond with hydrogen atoms. Each carbon forms bond with three different hydrogen atoms, and here duplet of hydrogen is also satisfied, and octet structure of carbon is also satisfied. See, for this carbon atom there are 8 electrons, 1 2 3 4 5 6 7 8. For this carbon atom also 1 2 3 4 5 6 7 8. And as we know, the shared pair of electrons will belong to both the atoms involved in the bonding. So overall, how many covalent bonds are here? I can represent this in the compact form as like this. So you can also count the number of covalent bonds here. 1, 2, 3, 4, 5, 6, 7. There are 7 covalent bonds here. In this way, we will draw the electron dot structure. Let us take one more example here. Propene. It is having the molecular formula C3H6. Here also we are writing the carbon atoms, and around each carbon atom we are going to write the valence electrons. There are 3 carbon atoms here. 1, 2, 3. Okay. And here the name suggests that there is one double bond in the molecule. There is one carbon-carbon double bond in the molecule. Okay. Now let me write the valence electrons. 1, 2, 3, 4. For this carbon atom also 1, 2, 3, 4. Why have I written here both the valence electrons here? I know that there is one double bond between these two carbon atoms. At least one carbon-carbon double bond is present in this molecule. So the shared pair of electrons will be 2 pairs here. So because of which I have written 2 electrons in this side only. And for double bonding, this carbon is used here. So it will also have 4 valence electrons. 1, 2, 3, 4. Again, why I have written both the electrons here only? Because I know there is a double bond between these two carbon atoms. And double bond is formed only when there is sharing of 2 pair of electrons. Yes, if there is only sharing of 1 pair of electron, I might have written only 1 valence electron on each side. Here I know that there are double bond. There is double bond between these carbon atoms, because of which I have written both the valence electrons in this side only. Okay. Now write the hydrogen atom. Each hydrogen has one valence electron. How many hydrogen atom will be for this carbon atom? As already one bond is present here. So remaining 3 hydrogen atom will be here. This what it represents? Already there is a bond between this carbon atom. Okay. And for this carbon atom, already there is presence of 3 bonds here. 1, 2, 3. And I need to write only one hydrogen for this in this way. Yes, because already there are 2 bonds here. And here there is one covalent bond between these 2 carbon atoms. So I have written only one hydrogen here. And in this case also you can see there are 2 bonds here. Remaining I need 2 hydrogens. So I will write here 2 hydrogens. Okay, in this way we will represent the electron dot structure. And you can also count the number of valence and you can also count the total electrons around each atom after bonding. Duplet of hydrogen is satisfied in all the cases. What about carbon? Here 1, 2, 3, 4, 5, 6, 7, 8. In case of this carbon atom 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All the valences are satisfied for all the carbon atoms. Okay. It can also be written in the compact form as, why is this double bond here? Because here there is a sharing of 2 pair of electrons. Okay. This is how we will write the electron dot structures for covalent compounds. And in the beginning of this chapter only we have seen These carbon compounds will form chains, branches and rings. Let us take the examples. They can form chains. Examples, take butane. Butane suggests that it consists of 4 carbon atoms and it is an alkane. It is an alkane. So, if these carbon atoms are arranged in the form of chain, we will get this. All these carbon atoms are in the form of chain. So, this is called as chain structure. This is called as chain structure. And there is possibility of these carbon atoms to be arranged in the manner. Write the skeletal structure. Yes, we know that it consists of 4 carbon atoms. And these carbon atoms may also be joined in this manner, forming a branch. Now you can satisfy the valency of each carbon atom by writing hydrogen. 1, 2, 3, 4. 1, 2, 3. Already 3 bonds are there. I can write only hydrogen, 1 hydrogen here. Here there is 1 bond, means remaining 3 bonds are to be written. Here there is 1 bond. So 1, 2, 3 more. This is branched structure. And you can observe here the number of atoms of carbon and hydrogens are same in both the cases. It is also having the molecular formula C4H10. Yes, both of them are having the molecular formula C4H10 here. This is also having C4H10 and this is also having C4H10. The only difference is the arrangement of the atoms here. So these type of compounds which have same molecular formula but different structures, they are called as structural isomers. Okay. So these type of compounds with same molecular formula but different structures, they are called as structural isomers. Why they are called structural isomers? Because they differ in their structures but have the same molecular formula. And these hydrocarbons can also exist in the form of ring structures. For example, here the carbon atoms are arranged in the form of ring and this compound is called as cyclohexane. And there may also be carbon-carbon double bond in the cyclic structure. And while satisfying valency, you should be very careful when there is double bond. Here already there are 3 bonds, so we need to write only 1 hydrogen here for this and this carbon atom. See here, this compound is called as cyclopentene. Cyclo because these are arranged in the form of ring. Pent because there is presence of 5 carbon atoms and ene because there is carbon-carbon double bond here. In this way, we will draw the cyclic structures for hydrocarbons. And there is one more popular cyclic hydrocarbon, that is, it is having carbon-carbon single bond arranged in an alternate manner. This has molecular formula C6H6 and this compound is called as benzene. In your higher classes, you are going to study the various reactions of this benzene. Yes, this is all about the cyclic structures of hydrocarbons. Then how can we draw the structure for cyclic hydrocarbons? Let us take example of cyclopentane. It has 5 carbon atoms. So I will write these 5 carbon atoms in the form of ring. Yes. Now we have to satisfy its valency with the available hydrogen atoms. There are 10 hydrogen atoms here. Okay. First let us see this carbon atom. Already 2 bonds are present. I will write here 1, 2. So that it will be having 4 bonds. Then this carbon also having 2 bonds here. It will be having 2 hydrogens. And this carbon atom is also having 2 bonds. So in this way. So while having any bond, we have to check whether the valency of each atom is satisfied. Okay, in this way we will draw the structure for cyclic hydrocarbons. Okay, let us solve some examples. Write the molecular formula of the compounds and write their electron dot structures. And this concept is very important. You should be able to write the molecular formula and also the electron dot structures for these compounds. Ethene, and it suggests that it belongs to alkenes. It is an alkene. And the word that is, it suggests that it is having two carbon atoms. Okay, we know that alkenes having the general formula CnH2n. So eth suggests that it is having two carbon atoms. So substituting 2 here, I will get 2 into 2. That is C2H4. What is the molecular formula of this compound? C2H4. And also we have to draw the electron dot structure for this compound. Okay, there are two carbon atoms. I need to write the valence electrons around each carbon atom, and I have already know that it is ene, means it consists of double bond. So while writing the valence electrons, I will write the two pair of electrons between these two carbon atoms. Okay, first I have written the C here. Now I will write the valence electrons. We know that valence electrons of each carbon atom will be 4. So it will be 1, 2. I am writing here both third and fourth electron here only. Why? Because I know it is having double bond. Double bond means it will share two pair of electrons. Double bond means it will be having two pair of electrons. So instead of writing only one electron between these two, I will write 2. Overall it is 4 only. And for this carbon also, I will write here 2 valence electron on this side only. Then remaining 2 electrons on this side. Now I have to bond this carbon with the hydrogen atoms. And here it is already having 2 bonds here. How many hydrogen atoms I need to make bond with the carbon atom? 2. It will be 2. We know that valence electron of hydrogen is only 1. Here also 1. In this case, it will be having 2 hydrogens only. Why we have written 2 hydrogens here? Already there are 2 bonds here between these carbon atoms, because we know that it is having double bond. Double bond means 2 pair of electrons. Okay. Now you can also count the number of electrons around each atom, whether their valences are satisfied. Hydrogen, it is satisfied, that is duplet. And in case of carbon, we are having 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And remember every time that whenever there is sharing of electrons, these electrons are belonging to both the atoms. Okay, here it has shared 2 pair of electrons, means these electrons are belonging to this carbon also and for this carbon also. Yes, this is electron dot structure for ethene. Now let us solve this. And by seeing this name only we can understand it is an alkyne. And alkynes have the general formula CnH2n minus 2. And it is eth, means it has 2 carbon atoms. So substituting 2 here, I get C2H2. So the molecular formula of the compound is C2H2. It is molecular formula. And also we have to draw the electron dot structure for this compound. Here there are 2 carbon atoms. So I will write 2 carbon atoms here. And also I know that there is a triple bond between these carbon atoms. Now I need to write the valence electrons here. Okay. I will write 1 valence electron here and 3 valence electrons here. Why? Because I know there is a sharing of 3 pair of electrons. Okay. For this carbon also, I will write 3 valence electron on this side only and remaining 1 electron here. Okay. Or you can also write valence electron here also. Total 1 carbon should get 4 valence electrons. Okay. Again, I am repeating why I have written all these 3 valence electron on this side, because it is sharing 3 electrons with the other carbon atom. How we have find out this? Because it is an alkyne. Alkyne means it should have triple bond. Triple bond means there is sharing of 3 pair of electrons in this way. Yes. Now I need to write the hydrogens here. Hydrogen will be having 1 valence electron. Each carbon atom needs only 1 hydrogen, because already there is presence of 3 bonds here. 3 bonds means remaining is only 1 bond here, that too with hydrogen. Okay. This is how ethyne dot structure is. These three pair of electron represents there is a triple bond between the carbon atoms. Okay, now you can count the carbon. Now if you can count the number of electrons around each carbon atom. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This is ethyne. In this way, we are going to write the electron dot structures for covalent compounds.